A rod AB, hinged at A and attached at B to cable BD, supports the load shown. Knowing that D is equal to 200 mm, determine A, the tension in cable BD, and B, the reaction at A. First, we have to determine the tension in the cable BD. The tension in cable BD. So first things first, we have to move T along the line BD. So now we're going to get the summation of moment A. So since the force is approaching northwest, so the moment is in the counterclockwise direction. So summation of moment of A is equal to 0. T sine 45 degrees times 0.2 meters plus 90 Newton times 0.1 meter plus 90 Newton times 0.2 meter is equal to 0. So we're going to calculate first this. So 90 0.1 plus 90 0.2 is equal to 27, and the 27 here we're going to transpose to the other side. So now we have T sine 45 degrees times 0.2 meter is equal to negative 27. So in order to get the T, we have to divide both sides by sine 45 degrees times 0.2 meters. So cancel, and cancel. So now we have T is equal to negative 27 over sine 45 times 0.2. So now we have the negative 190.9 Newton. But remember that the moment of A is in counterclockwise direction, so the final answer should be positive. So now we have the final answer of 190.9 Newton. So this is the answer for letter A. So first we are going to solve for summation of force of X. Is equal to 0. So a sub x minus 190.9 Newton times cosine 45 degrees is equal to 0. So transpose this to the other side. So we have ax is equal to 190.9 Newton times cosine 45 degrees. So ax is equal to 190.9 times cos sine 45. So we have 134.98, or is approximately 135 Newton. So this is the value for your ax. So next one is we are going to solve the summation of force of y. So ay minus 90 Newton minus 90 Newton plus 190.9 Newton times sine 45 degrees is equal to 0. So once again, transpose this to the other side. So we have ay is equal to 90 plus 90 minus 190.9 Newton times sine 45 degrees. So solving for ay, we have 90 plus 90 minus 190.9 times sine 45 degrees. So we have the answer of 45 Newton. So in order to get the A is equal to 135 Newton squared plus 45 Newton squared, then square root. So we have the final answer of 142.30 Newton. In order to get the angle, we have 45 degrees here. This is the AY, and the 135 newtons, this is the AX, and this is the A. So tan inverse 45 newtons over 135 newtons, we have the angle of 18.43 degrees.